So welcome to the first session of Virtual FoxFest 2021. My name is Christoph Wollenhaupt, and today I'm talking about WPF and Visual FoxPro. First, I'd like to talk a little bit about me. I've been very long, I've been doing FoxPro for a long time. It's approaching 352 months now, but I also do .NET and web development. I've been an international speaker for a long time, a contributing editor for FoxPro Advisor, published many articles and magazines when we had FoxPro magazines, and also have been a Microsoft MVP for FoxPro from 97 to 2010. I'm also the co-owner of FoxPad, a German company that is doing FoxPro. So if your FoxPro developers are close approaching retirement, well, I'm not. I have to work for a long time. So if you need any FoxPro experts in Europe, you have just found them. And this session as agenda is why would you use WPF at all? And how do you use WPF in FoxPro? What about XAML? What's that? And once you listen to this session, what's the next step? How do you get forward doing WPF work? So the scope of the session is not all you need to know about WPF in 75 minutes. No, because I can't talk that fast. I would have to talk very fast. It's actually, if WPF is a universe, what we talk about is not even a solar system, a planet, it's just a mountain, maybe a hill, but it will be the first hill that you need to get over. So it's about getting started in WPF. It's not about everything there is to WPF. And when I said modern UI, I'm not saying stunning UI. I'm not saying awesome design, visually pleasing designs, great animations, superior UX, UI experience. You won't see any of that. Most of the samples are text boxes, labels, list boxes, and they look as boring as they look in VFP. But it's a modern UI because you have great potential. But it's up to you to use that potential. It's not something that we can cover in 75 minutes. So why would you use WPF at all in a FoxPro application? I came across this problem when a customer who has a mobile application wanted to connect car owners with car repair shops. We are doing the software for the car repair shop. They have other software for car repair shops. One is a back-end web application catalog system where the car repair shops can pick the parts, search for parts that a wholesaler provides by car type and by part that's missing, and do all kinds of things. Our application is handling invoicing and all of this stuff. So they created a new application that is meant for the car owner to being able to contact the repair shop using chat. Previously, in Germany, if you wanted to contact a repair shop, you would call or you would visit. Younger people, they don't want to make calls at times that is inconvenient for them, or they don't want to visit. They just want to chat. And they want to send pictures. They want to send videos. And if they have a strange sound, which is one of the reasons you contact a garage or repair shop or garage, they want to send the sound. They want to record the sound and send it to the repair shop so they can tell you if you need to come urgently or if you can make an appointment at a later time. So all of this communication between the car owner and the repair shop is handled in this chat application. And they have a web application. The request was to make this look like what they have in the web. The problem was the web application was using REST APIs for accessing chats and authorization. It's using SignalR for sending and receiving chat messages. As soon as a chat message is sent, it's received on the other side and it's shown, just like you would expect from a chat application. There was application-specific JSON messages because it's not just text messages. You can also exchange car data. What type of model is it? What make is it? what's your VIN, what's your license plate number. And you can exchange customer data like your email address, your address, telephone number. There's feature for appointment requests. You can ask for an appointment, and the repair shop is confirming the time of the appointment and sending you back a VCal file that you can add to your calendar. You can upload photos, videos, and audio recordings. And because the repair shop is in the business to make money, they can also send you offers and invoices, where the offers you can accept or reject, and the invoices you can pay. So the task was make it look like a web application, or like the web application. The first attempt we tried was FoxPro. And while you can do everything of this in FoxPro, it really, really is difficult to do. There's a lot of things you need to do to make SignalR work in FoxPro. It's if you have a design that needs to show videos inline in a scrollable container, that's a lot of work. Playing audio files is a lot of work. So we quickly gave this up and tried a second attempt. This happened shortly after last year's session about FP Sharp. So I was suggesting we can use the existing web application, take the existing chat module, and just plug it into a new shallow shell and replace all the backend services with VFP code. So because in Sharp, we can intercept calls to a backend and send a different response instead. So instead of talking to the actual backend service, they would talk to our VFP application. The advantage would be that we wouldn't have to do the front end. It's a different team that's doing the front end development, and whenever they have something new, we can use it. Turned out that a React application that uses the chat module as a component it's not as easy as taking out the chat module. There are lots of dependencies, custom build processes, custom repositories for all these modules. So it was a lot of work to just get this out and isolate the module. So we scrapped this, and instead we did a WPF control for the chat module. No. So this is inside the application. I cannot show you all the details, but as you can see, there's a chat in this here. The right side is the repair shop. I can send messages, have them appear in the chat. They also appear on the mobile. I can have pictures, and while the entire UI is WPF, I can still call FoxPro forms and go back to the WPF form. So it's not just the UI that is being handled inside this WPF control. It's also using the SignalR processing and JSON parsing capabilities of .NET. It's using this data from the JSON, from the web service, from the backend, augments it with data from the VFP application so that we link vehicles, customers together. We call VFP forms to show details, and we call VFP methods to do all the processing. So if the customer wants to make an appointment, we can click on buttons in the WPF front end, and then we call our business objects written in FoxPro to handle all of this. So far, any questions?
Nope.
Wonderful. So how do you use WPF? The basic foundation of that is the FP.NET control, the same control that I used for FP Sharp. My intention was, at least for me, to be the last ActiveX control that I ever use. I don't want to have a lot of ActiveX controls when there's tons of Win forms, tons of WPF forms available. FP.NET is this tiny ActiveX control that hosts any WinForm control that is any WinForm control, basically. It uses .NET Bridge from Rickstral to actually do the communication. The way this works is, and we have to go into app domains very briefly. In .NET, the app domain is the layer of isolation. Everything within one app domain can talk to each other. References work, object references work, method can be called. Everything that's in a different app domain runs in the same process, but you cannot talk to it just like you can with objects inside the app domain. It's more like a remote machine or remote process. You have to do marshalling in order to communicate to other objects, just like remote communication. So what happens usually is that if you run .NET Bridge creates its own app domain, and everything you load in .NET Bridge, it's loaded into this app domain. ActiveX controls, on the other hand, that are .NET controls, are loaded into a different app domain. So the default .NET Bridge does not work on using accessing the UI controls. So FP.NET is running inside the UI app domain and then uses the .NET Bridge DLL to create an instance of .NET Bridge inside this app domain and makes it available to the FoxPro code. So it's actually just a few lines of code, but it means that my instance of .NET Bridge is running in the same app domain as the UI, so I can modify the UI. We've seen this last year in FP C# to host the C# component, and we will do the same thing using WPF in this session. In order to host, or the FP.NET control is used to host a WinForm control. So in order to host WPF, you need to have a WinForm control that hosts WPF. And that control, fortunately, exists and is called the element host. The element host is a WinForm control that has a single child property where you can assign a WPF property. So once WPF object, sorry. So once you set the child property of that element host property, the WPF control is shown on the screen. There's one thing you need to be aware, that is DPI awareness. The element host will, by default, or as soon as the element host becomes visible, it will turn on DPI awareness for the current process. So if you're running at 200%, your FoxPro application suddenly becomes 50% smaller. So you need to prevent your application from changing. And one way to do this is to, in the property settings, come on. Right click. Try again. Properties, and there's compatibility, and then there's change high DPI settings. And if you have more than 100%, you can change this option, override high DPI scaling behavior. And if you change it to system, that will prevent the element host to be able to change it to DPI awareness. Your application is still non-DPI aware, and Windows does all the scaling for you. There's a session by Tracy on high DPI where you can find a lot more information about this. So it's just the element host by default wants to turn on DPI awareness. So in order to make this more simple for you to use, there's an FP WPF program that is part of the session notes. You have an older version in the session notes right now. There's an updated version already that you will get in the next days. So what the control does is it's instantiating, or it's actually loading a couple of WPF assemblies. So it's all the WPF controls are available. And then it's instantiating the element hosts and calling the setControl method, which is showing the WinForm control, and then it's setting the child property, which is showing the WPF control. So back to the slide. Also has support for data binding that we look at later today. So what is WPF? WPF is Windows Presentation Foundation, and it's a desktop UI for Windows. Historically, there has been WinForm, WPF, and the current version is WinUI.NET MAUI. WPF is not the same as XAML. XAML is something different. It's used for WPF, but it's not WPF. So, and to highlight this, the first samples I'm going to show you are not using XAML at all. So how do you add controls to a form? This gray control here is the FP.NET control, which is called host. And the first thing is we create, or we call the WPF bind to host method to connect a stack panel to the host control. Then we get the bridge that is working in the app domain of the form. A regular .NET bridge would work in a different app domain and not be able to talk to the control. Then we just create an instance of a label. You always have to give the full name using a .NET bridge. So it's system Windows controls label. Then we set the content property to last name. We create an instance of a text box, and then we get the children collection of the panel at both controls. And what we get is something boring looking, but this is WPF. You can see this easily if you type some text and then go to JARMAP, copy some Arabic signs, put them in the middle. And unlike in Visual FoxPro, you actually see Arabic countries. And what I'm now doing is I'm pressing the right arrow key on my keyboard. So I'm going one character to the right. And you see WPF is doing all the left to right to left, and it's even doing this inline. So it's a lot more capable than what we have in VFP. So the one thing you remember or you see is that WPF is hierarchical. You have one element at the top, and then you add more and more controls. In WPF, we have lots and lots of controls, and there's a lot of complexity involved. For instance, there's a label control and then the text box control. Both seem to do the same thing. Both display text, except the label control is a content control. And as you can see from the hierarchy, inheritance hierarchy, object is then that's subclass dispatcher object, which subclass is dependency object, visual UI element, framework element, control. Content control, and finally label. So there are like 9 levels of inheritance just to display text. Text blocks is a lot easier. It's, I think, a UI element or framework element, so it doesn't have all the complexity of a control. What you also encounter in WPF is that WPF doesn't always behave as you expect. What I'm doing here is I'm doing the same thing as I did before. I'm adding a label and a text box, and this time I'm doing it 50 times in a loop. So now I have 50 labels and 50 text boxes, and if you see as I tap through, nothing happens. The cursor disappeared, and if I resize, it's down here. There is tons of lists, text boxes and labels, but it doesn't scroll. That's because in WPF, a lot of the features are separated into separate classes. So if you want to have something that scrolls, you need a scroll viewer. Scroll viewer at the top, we add the scroll viewer, we add the stack panel and everything else we had before. And if we do this, we now can scroll through the list, through all these labels, and tap through and have it work like we expect. It's not built into the panel. It is a different class that you need to use in order to get the functionality. And that's because WPF is better at the separation of concerns than, for instance, WinForms. Often WPF controls only do one thing. There are some more complex controls, but often they separate what they do. In addition, they also separate the behavior. So like a list box, the behavior of a list box is having a selected item, and if you press the down arrow key to select the next item, if you press the up arrow key to select the previous item. They have state, like whether an item is selected or not, or whether the mouse is over a button or not, or a button is pressed or not pressed. And they have UI, and you can control all of them separately. So there are a lot of things, or a lot of times, you need more WPF controls than you would in WinForms or in FoxPro, or more than you expect as a FoxPro developer. You can also mix and match all of the controls. Let's look at an example that you shouldn't repeat or shouldn't do yourself. So instead, this time, instead of starting with a scroll viewer, we start with a button. And then we add a scroll viewer to the button, and then we add a stack panel, and then we add 50 labels and to this button. If we run this, we now have a button. You can see the mouse. If I move the mouse over, it highlights as the button does. And if I click it, it slightly changes the color and the click event fires. Still, I have a list box in the button as the caption. So it's not just multi-line button lines and images that you can add to a button. You can add any control you want to a button. So content is really king for WPF. Content can be anything. But when you can do everything, you have to be responsible. You probably remember the early WPF applications that overdid a little bit what they could do and were slow and difficult to use because there was so much they tried to do at once. Any questions so far?
Nope.
So let's talk about data binding, because that's what we want to do as a FoxPro developer. The one way we can do binding is It's a very simple binding. So in this case, I'm again creating controls. This time I'm creating a text box, and I also add the WPF control as a text box property to the host, so I have it available for later because I need to access the text box. In the load event, I create a cursor, and then you see that I have a refresh method in the host control. Whenever the host control is refreshed, so when the form is refreshed, it will get the data from the cursor and put it into the text property of the text box. When you access data from FoxPro and send it to .NET, you have to be aware that if you have a character field in a cursor, this character field is padded with blanks. A FoxPro text box automatically removes all the blanks at the end. A .NET text box would not. So you have to trim the text and send it back to the control. So what we now have is I have a WPF control at the top, I have a FoxPro text box at the bottom, and if I make changes in here and go in there, the control is updated. The opposite is not true. If I make changes here and then go to the FoxPro control and back to the WPF control, you see that I don't have the content updated because it's a one-way binding. I just reading and refresh. I'm not updating or writing back any changes made in .NET. To do this, I extended, in the second example, I used the lost focus event of the host control to read the text property of the text box compared to the data that is stored in the cursor using trim to get rid of any blanks. And if it's different, I'm updating the cursor. So now anything I change in the .NET control is also updated in FoxPro and vice versa. If I change things back here, any change is stored in the cursor and displayed correctly. That makes it possible to bind data, but you can imagine that is not the way you actually want to work. It's not even like in FoxPro. It's probably more like 2.6 and maybe even earlier than 2.6. So what you really want to have is using some binding, like something like a control source. And WPF, that's what we did. WPF has binding, but there's no control source property. Instead, they have something called a data context and a binding path, and then fill a dependency property with the binding expression. What this looks like is this. So let's look at another example where we actually use .NET binding. So we, again, create a stack panel, we get the .NET bridge, and then we set the data context property. The data context property of the panel is an object. In .NET, everything is stored in objects. They don't have the differences that we have, where we can use properties as a control source and fields as a control source. They only have objects. The data context, setting the data context means that an object and all of its child objects should access the object that you specified. So I'm basically saying the panel is working on the underscore VFP object. And then when I'm adding a text box to that panel, I can get a static property called text property, which is the dependency property for the text property with a blank in between. So the text box has a text property and it has a text property. Text property is a static property which has a couple of methods. One is being the set binding. So I pass in, I call the set binding, no, I call the set binding method for the text box, passing in the text property and the binding expression, and say, I want to bind this to the caption property. So caption is the path, underscore VFP is the data context, which means that the text box is supposed to show the caption of the VFP instance, which is the screen caption we see at the top. When I run this, you see that I have the screen caption of my window. And if I enter something and leave the text box, you see that the screen window at the top updates. And if I change this back, updates too. So it's a two-way two-way binding, and it's live updating the underscore VFP caption object. So it should be simple. We just set just use some object here, set the property here, and you're good to go. Except that's not going to work. So let's look at a slightly different sample. The only change I made is I replaced underscore VFP with underscore screen, which is the same, basically the same text. So the caption property of underscore screen is identical to the caption property of underscore VFP. But there's a big difference. Now you see that the text box is empty, and typing anything in won't change anything. Nothing happens at all. So why is that? If you bind to screen instead of VFP, we bind to a different object that is behaving entirely different. But before that, one of the things in WPF that is in binding that is really, really frustrating is that whenever you have a binding error, nothing happens. You don't get an error message. You get nothing. The only thing that you notice that there's a binding error is because the text box is empty. So the expression must be wrong, but it doesn't tell you why it's wrong and that it was wrong. You only notice it when you look at the empty text box. So the difference here is that the way how binding works. Binding in WPF requires that WPF gets a list of all properties and all methods that an object has available. So there are two ways to access a COM object, which we are using between WPF and FoxPro. One is the IDispatch interface, where you're actually asking for a specific property, and then you get the number, the disp ID back, and then you can use that disp ID to invoke the methods. That works when you know the property. You can ask COM object, do you have this property? Can I get this? And then there are type libraries. Type libraries give a list of all the properties that an object has. And binding is relying on type libraries and COM. It wants to know all the properties. It doesn't check every single property. So it wants to know all the properties, and it needs to have a type library. So what does the screen object look like to .NET? There's an easy way to find this out. If you use the underscore eval function and pass in any FoxPro object, what you get back is a COM object, because underscore VFP is a COM object, and it returns a COM object. Then we use A members to get all the members that this object has listed, and we also display the caption. So we check, do we have a caption object? And as you can see, we have in the list, we have no members, but we can still access the caption. A members is using the type library. So it's getting all the known properties, which are none, and accessing the caption properties using the iDispatch interface, which is trying to get, do we have a caption property? So what we need to do is we need to make sure that we have a type library available for binding to work. Any questions?
No, still no questions. Reminder to everyone, put your questions in the stage chat.
So one way to make this possible is if we create a COM server in FoxPro. So this is a binding class. It has a caption property. And because the way that COM works, we also want to make sure that we use the COM attrib array, where we specify how the caption is, the casing of the caption property. Otherwise, you would end up with an uppercase caption property instead of a proper case caption property. In addition, we have a reference to the VFP object that we use. Then we use access and assign methods to redirect the COM object call to the screen property. And we have a method to set the screen object. The COM server is running as a DLL. So it's actually not running in your main application's environment. It's running in a separate instance of FoxPro, in a separate runtime environment. So it doesn't have access to all the tables and all the objects. It's basically acts only as a proxy. So we create the COM object. We have to create it as a COM object. We cannot use the FoxPro object. Then we call the setScreen object method, passing in our screen, which is then converted to a COM object, which is stored in our other COM object, and assign the COM object as the data context. And now you actually get access to the screen object by using a proxy. Problem is, you have to register the COM server. It's another server you need to register. Just in order to get access to data, there's another DLL that you need to build, another DLL that you need to maintain and ship, and then register as an administrator. So that's not necessarily the best way to do this. Another approach would be to use a .NET library instead. We don't have to register a .NET library. We can just create it using WPF. We need Visual Studio for that. Oops. But I'm just showing you what this code looks like. So that's net binding. Simple class, we have a class that's using a dynamic property. Dynamic means for C# that it doesn't know anything about the properties, but if you access a property, it will just try to get the property like here. It won't complain if at compile time if the property doesn't exist. It will complain at runtime, just like in FoxPro. So you can use any property, but it has to be there at runtime. So this is using the iDispatch interface, which means that we can access the caption property from C# because we are not reading the type library. Using this then is a matter of instantiating loading the .NET binding DLL, instantiating an instance of net binding.screen, passing in the screen object, and then doing everything the same way. And I wished I could run this sample. It did work at 9. It stopped working somewhere between 9 and 4 when I tested it again, and now crashes FoxPro. So we have to skip this sample, but it's a complex way anyway. So let's get to a better way of dealing with control sources, because so far, none of these approaches are really exciting and not as simple as what we are used to in FoxPro, which is setting a control source property. So we do some tricks. We cheat a little bit. We use an indexer. You know indexers in FoxPro from collections. A collection has an item array or has a list of items, and you can access an item either by specifying item and then in square brackets the index, or you can just use the collection. In .NET, the same is possible. We can just access an object just using the index and then refer to another property inside the object. This is called the default indexer, or this indexer in .NET. And we have something in FoxPro that we also have in .NET, is when we have an array and have an access and assign method, we can pass whatever we want, or not actually whatever we want. We can pass numbers and strings into the array and then use the access and assign method to look up or use the string to get the actual array element. So we do the same thing in .NET, and it's using a small DLL. In this case, basically receiving a VFP instance, and then it's using the VFP eval function method and the setvar and do command method to change the property value. So this is looking like this. Again, we have the assembly. We create the data source instance, and then we set the caption. And as you can see here, we use square brackets, and inside square brackets, we are supposed to put an index like 0 or 1 or string. But the string we use is just a FoxPro expression. And because this is passed to our source, where we use the underscore VFP object that we passed into, and use the eval, we can evaluate any FoxPro expression that we want. So if I run this, you see that I now have the screen caption in uppercase. It's read-only because it's an expression. I cannot put it back into upper screen.caption, just like I couldn't do in FoxPro. So this allows us to use any FoxPro expression that we want. Let's go back. But it does have a few limitations. Because we use the underscore VFP object, there's no this or this form. It also only operates in the default data session. And we created a public variable that you briefly saw in the source code. And it only updates variables. It uses the assignment operation to store back the value, or the store command. And that only works on variables. It doesn't work on fields. So this isn't the perfect solution that we really wanted. So let me restart VFP, because otherwise we will see a crash again. And let's look at another approach. In this case, we are using WPF again, and we have another class in there. It's a data context class. The data context class is similar to what we've seen in C#. It's creating a data context object, which is then calling the get methods and the set methods in this class. And this is then passing the expression. So it's a read-only expression. It's a single field name. It's an alias field name. And it's basically updates fields and everything. We don't have to look at the code because we are only going to use this. So in this case, I put the code to add the text box into a method, and then we create a text box, And we use different versions of control source. We use customers.custom number, customers company name. We use two expressions. One is read-only, and this one is in parents, it's definitely read-only. This last order is a datetime field. This form.width is a numeric field. This form caption and screen caption. And if we run this form, you see that all the fields are in there. So if I change this field in here, all the other fields are automatically updated. And it's updating the cursor behind the scenes. If I change the caption of the form, changing the caption of the form, it's the same for the screen caption. There's some limitation, though. If I change the width of the form to, say, 650, you notice nothing changes, and it switches back to 609. That's because the text box control only uses, in .NET, only uses text. It can convert a string into a numeric value into something to display, but it doesn't have the ability to pass back the numeric value and return it or set it as a numeric value. It's always a string value. If you do the same thing with a datetime, it's not just ignored. We get a data error message, and it actually says that you get the error message here if the control source is wrong, because this is trying to put a string value into a datetime field, and that's not working either. So there are some limitations. I'm working on an enhanced version, but for now, that's still, I think, quite useful, because you can use fields and variables, everything you have on a form, and just assign it as a binding data source. So any question about data sources and binding, because that's the last thing we talk about binding for now.
No questions about that.
No.
I've got one that's marked as for the end of the session, so
Okay.
we'll do that one.
Let's talk about handling events, because showing data is one thing, but what you really want to do is you want to respond to events. So in this case, I'm adding buttons. I'm adding 3 buttons. The content of is button 3, and then I'm using .NET Bridge, the subscribe to events method. Subscribe to events takes a .NET object and a handler object written in FoxPro. And every event that is in the .NET object is bound to an on method in the FoxPro object. So if I have a button that has a click event, subscribe to events will call the onClick method in the object I passed as the second parameter. You always get back a subscription object, and this subscription object, you need to do something in the query unload or unload event. You have to unsubscribe, otherwise you end up with dangling references and memory leaks. So let's look at the onClick method. All 3 buttons trigger the same onClick method because they all buttons are handled by this form. You could use a different handler for every object if you want. In this case, I used one handler, and I wanted to show you what you need to do in order to find out what object was triggered the event. Because what you might do is you might look at the sender, which is the object that triggered the event, and compare the reference to the one that you stored, button 1. This doesn't work because while it's the same .NET object that is in the background, it's a different FoxPro object. FoxPro has its own wrapper for the .NET object, and it creates a different wrapper every time you access the .NET object. So button 1 is the .NET wrapper that we created initially. TO sender is a .NET wrapper that was created later, and they are not the same FoxPro object. They just point to the same .NET object. So you need to call the equals method on the object that triggered the event and compare to the .NET control that you have stored in the host in this case. And if you use this, if you click, you remember that I've compared to button 1. Compare references says no, they are not identical, but equals says yes, this was button 1, button 2, and button 3. So this is how you respond to events. Subscribe to events in .NET Bridge, handled by the on method And you can either pick one handler per WPF object or have one handler for several objects where you use the equals method to distinguish them. There are two versions of www.net Bridge, actually. One is by Rick Strahl, and one is where I made a few little modifications. And the one I use in the samples has a little extra that if a method does not exist, so if there's an lost focus event and you don't have an unlost focus event in FoxPro, what the original .NET Bridge does, it's binding to the event and then just ignoring the error message when it's calling the unlost focus method in FoxPro, whereas my code is looking if the lost focus event is available and then not binding if it's not available. It shouldn't make a difference, except I encountered some badly written code in .NET that would act differently when there was an event handler bound to an event versus when no event handler was bound. And some even expected the event handler to change certain properties in the event object that is passed into the event. So it didn't work when it was bound to everything, so I needed this. But this code should work with both versions of .NET Bridge. You can pick whatever you want. Comparing references might not be the ideal solution. There's also a name property in WPF. It's optional and there's no default. So if you create a new text box, it's not text box 1 like in FoxPro. It just doesn't have a name at all. And names have to be unique within the name scope. But if you don't use a name scope, like we don't use in this case, both names don't have to be equal. So we set the name property of the first button to button 1, of the second button to button 2, and of the third button to button 1. And this is intentional. It's not a typo. When we run this, you see that button 2 causes button 2 clicked, and button 3 causes, again, button 1 clicked. That is in the onClick method. So it's just getting the name property, and then it's using that name. And in this case, you could use a do case statement and do different things based on what button was clicked or what control triggered the click event. So there are two methods to separate distinguish objects. It's either reference using the equal method, or it's using the name property. You might notice that I clicked a lot. So let's look at a sample where I created 3 text boxes in WPF and 2 text boxes in FoxPro, and the tab order is 1, 2, 3. When I tap through the WPF control, you notice that it's going back. You cannot leave. Once you enter the WPF control, the element host will just cycle inside the WPF control. And that's not necessarily a good user interface, obviously. So what can you do about this? What we do is we bind to the preview key down event of the last text box in our init where we created the control. So we have the text box 3 and subscribe to events, and then use the on preview key down to get the key that was pressed. And when it's the tab key, which is 3 for some reason, we just set the focus to our FoxPro text2 object, which is this guy over here, and then set the handle property in the event args to true so that WPF does not handle the event itself. If we run this, the yellow indicates which FoxPro object has the focus. You see that we can tap through all, but you also see that there's a little flickering sometimes. Sometimes when I leave the third one, the focus first goes to the first one and then goes to the last one. So it's not working flawlessly. That's a timing issue that you can't really avoid. And so far, we only handled tapping. We didn't handle shift tapping, which is going backward. And this is where it's really getting a lot more difficult. So, because surprisingly, shift tab has the same code. It's 3. And there's no modifier that is passed with the on preview key or a preview key event, you have to use you get the message that a tab key has been pressed through Windows messages. And then you can question or get the current key state of a control using the get key states object. So we ask for the left, and we also have to do this for both shift keys. So left shift key and right shift key, we ask if the left shift key is currently pressed. If the computer is busy, it might be that the tab message has been delivered after the shift key has been released. So you might get a different key state at the time of asking than when the key was actually pressed. To make this more complicated, .NET also has not only a press state, but also a toggle state. So if I have the shift key and it's not pressed, it's 0. If I push it down, it's now pressed and the state is 1. If I leave it, it's now unpressed but toggled, which is 2. If I press it again, it's now pressed and toggled, which is 3. And if I leave it, it's now unpressed and untoggled, which is 0. So it's the shift key goes through 0, 1, 2, 3 in states, and every second time you press the shift key, you also have this. Only then you have the same toggle state. So you need to check for 0 and 2, and for left and right shift key, just in order to figure out whether the tab key was pressed. But then you can actually go backward through the tab order and forward in both directions. Well, actually, we implemented this. So that's for the tab order. So you always have to do this if you integrate a control into a VFP form and you have a VFP controls before and after, and you want to have tabs support. So let's look at some other data control. Let's look at the list box. The list box starts with just adding data. The list box is a list box control and it has an add method where you can add an item. So in this case, we just add 50 strings and we have a list box, regular list box that has 50 items. In order to find out which element is the one that has been selected, you can produce a selected item. So if I have no items selected, I get null. If I select an item, and press selected, I get item 8. Yep. I also can change the selected item. I can set it. In this case, I'm setting it to 35. If I press the button, you notice that nothing happened except that the item 35 is being selected. It's not being scrolled to item 35. That's because it's a different control, and you have to call the scroll into view method, passing the item that you want to be seen in the view in order to make it selected and visible. So one of these many things in WPF that just behave different than what we see in FoxPro. The list box control not only can have simple text, contain simple text, you can also have more complex content. So in this case, we are creating a run, which is just like in Word. It's a combination of formatted text. We create some bold text that is red, put it into text blocks, add it to inlines. You have to be careful that you're not calling the add method directly, because that crashes your application. You have to invoke method and passing the add method. We add a checkbox, and then we create a listbox item and add everything to the listbox item. You kind of see that in WPF, if you do it in code, you have to create this backwards. The innermost items first, and then add them. So you build the outermost item, which is the listbox item, last. When I run this, we have a listbox that has formatted text, bold text, red text, and it also has a checkbox that you can check. While this is neat, one thing you have to keep in mind is performance. This was 50 items. Now I'm getting this to 10,000 items. And you can see it's taking a lot longer, and it's also blocking the UI thread. we are waiting and waiting about 7 seconds until until the items are there, but then we have all 10,000 items in our list box. So WPF controls do not work by default with large data sets. There are ways around it, like virtualizing panels and everything, but it's another topic, and it's way more than we can cover in this session. So far, how to create WPF code in code. But what about XAML? What is XAML? XAML is the abbreviation for Extensible Application Markup Language, and it's used by WPF, by Silverlight, and by WinUI. If you see the WPF, you always or usually see XAML, and you might think that all this XAML is the same, but it's not. It's just XAML is just a method to implement user interfaces for different systems, for WPF, Silverlight, and all of these. In WPF, there are two ways that XAML is being used. The normal way is using Visual Studio, creating a XAML file, compiling it into BAML, which is Binary Application Markup Language, and then Visual Studio generates code that where application.load component is used to load it from a resource inside your application. What we do is, or we can do is, we can use the XAML reader object and call the parse method, passing in XAML and getting back an object that represents the XAML. If you just take the object that created in Visual Studio, you will end up with an error message. Because Visual Studio expects that you have a code behind file, which you don't. If you load XAML, you have to remove this line, and if you remove anything that starts with X, with the X namespace, which is all the compiling and code behind stuff, then you can actually run this and get an object. In this case, the XAML object contains a lot of a number of shapes. Some UI basics very quickly. Expressing coordinates can happen in physical pixels. That's what Visual FoxPro does in WinForm. 1 pixel in your code is 1 pixel on the screen. WPF uses device-independent pixels, so it's still based on pixels, but they are scaled according to the device resolution. And then there are measurements that are relative to font size, which is very popular in web applications, like EM, using the voxels and FoxPro. So anything is sized according to whatever the font is. WPF uses independent pixel, where 1 pixel is a 96th of an inch, or 96 pixels equal 1 inch equal 2.54 centimeters, or 72 points. Those are the values you can use. A pixel is not an integer, a pixel is a decimal. So you can have a third of a pixel and display a third of a pixel, and if your resolution is actually 3 times higher, you get exactly 1 physical pixel for a third device-independent pixel. On lower resolutions, you might get a 1 pixel line that is, instead of black, for instance, is gray. The other difference in WPF is how it's rendered. WinForms and FoxPro use UDI+, which is the native API that is built into Windows. WPF uses DirectX, which is the same as games or anything 3D. So it's using completely different rendering mechanism. At the time that it was created, it was unusual for business application to require DirectX. These days, everything else is, or most things are actually DirectX. When you lay out things in WPF, you have 2 choices. You can use absolute positioning. That's the canvas object. In the canvas object, you can put a text box, for instance, or a label, and you can specify top, left, bottom, right, height, and width, which is 2 properties more than you have in Visual FoxPro, but it's very similar. So you can absolutely position any control on this canvas, but you don't get the benefit of flow layout, which is one of the great things in WPF. For flow layout or relative positioning, use a number of panels. A web panel puts everything that's inside the panel next to each other. And if the line is full, it just wraps around and starts a new line. The stack panel, on the other hand, just stacks everything. It starts at the top, and then every control is just put below or next to each other until it runs out of content. The dock panel puts things on either side, and then one remaining item fills out the middle part, everything in the middle. And the grid is not a data grid. The grid is just a grid where you can position things by column and by row, spanning multiple columns, spanning multiple rows. This is combined with margin. The margin is the distance between the control and the surrounding control, the space outside of the control that basically has to remain empty. Most controls actually have margin, a margin property. So let's take a look at a very simple form. So we have the XAML here. We use a grid, background crimson, and a border aqua, and a stack panel console. And you see, the only thing visible is actually the stack panel background. That's because the grid fills the entire content with the border control, which fills the entire content with the stack panel, and the border that doesn't have a padding doesn't show up at all. So the only thing you see is the stack panel. This line is a line that is going across the control, but because this is an ActiveX control, anything that's VFP draws appears behind the controls. FoxPro cannot draw on top of an ActiveX control. So this denotes the border of the VFP world and the WPF world. Let's look at a little different sample. In this case, we added a margin to the grid and a margin to the border controls. So this gray area between the line and the crimson border, that's the margin of the grid. And then we see crimson, that's the margin of the aqua border. We don't see aqua in here because the border still has no padding, and the stack panel is filling out the entire border. Padding means the distance between the border of a control and the content inside the control. So margin is between the border and the next control outside, padding between the border and whatever is inside control. Not all controls have padding. Actually, only few controls have padding. Only those that have a border and content, because it's a difference between the border and the content. Let's look at another sample. In this case, we added padding 20 to the border. So we now see the border control starts here. Then we have padding of 20 pixels, and then we have the content with the console stack panel, and we still don't see anything on the inner border controls because we didn't specify any margins or any paddings. So let's change that. Now we have margins for the margins over here, margins for the border control and padding for the border control. So this is margin 20 in the stack panel. Then we see the border control, and you see this is higher than this height. That's because this is actually the 15 pixel, the top border, and 15 pixel, the bottom border. And then margin does not collapse. So we have 20 pixels of margin for the first border, then 20 pixels of margin for the second border, then 35, another 35 for the padding, and then another 20 pixels of margin for both controls. So if you want to format them evenly, like 20 pixels apart, you actually have to specify different margins, different paddings. Actually, different margins. Now, we don't specify a single value. We specify 4 different values. So we make the first control have a padding of 10 at the bottom, the next have a padding of 10 at the top and the bottom, and the final one have a padding of 10 at the top, and then 20 for everything else. So how do you remember which value is what property? That's actually easy to remember. If you remember that writing this code is your job. Your job is going from 9 to 5. You start at 9 on the left, 12 at the top, if you look at the watch clock, then at 3 to the right, and then because you always work overtime, at 6 at the bottom. So it's left, top, right, bottom, 9 to 5. Easy to remember. So we can now combine all of this to create data entry forms. And we use panels, margin paddings to lay out everything, and then we use data binding. So let's look at a few examples. Form 1. In Form 1, we use a grid. We have row definition where we set the height to auto, and a row where we don't set the height, so it's taking all the remaining space. And for every control, we specify the row number and the column. And you actually have to specify the row number and the column. You cannot just add controls and have it be in the next row. If you insert a row, you have to renumber things just like you did in BASIC in the ancient years. What you notice is that WPF is sometimes a little bit unexpected. This text box is higher than this text box, even though it doesn't look any different. This text is a little bit lower than this text compared to the text box. And this looks like an edit box, but if I enter text in line 1 and then press enter, and then try line 2, nothing happens. So let's fix all of these, because this is one of the things you will run into quite a bit in WPF. It kind of works, and then there's some things that don't really work as expected. They are all logical, but you have to think about what it actually means and how the controls behave. So for instance, we add, because the grid will always use the full height, and the text box is a little bit smaller than the label, actually, even though it doesn't look like this. We have to add margin to the text, to the label in the first row to shift it down, or actually to the bottom, to shift it a little bit up, to make it higher, and then add a margin to the text box and some padding as well. So they all have the same size, and the largest control defines how large the text box and the labels is. To fix the enter button, we also have to set the accept return property to true. When we do this, we can actually line 1, line 2, type more than one line in there. And all the text boxes and all the labels are now equally sized. Let's look at some data. So we have a cursor, we have some data, and we have XAML. XAML. Yep. Oh, that's form, sorry. Form 3 XAML. And here we use the binding expression. We set the text property to a binding expression that is a curly brace followed by the text binding and a blank, and then the binding expression that we've seen before in square brackets, a FoxPro expression. When we do this, we actually bind data to the cursor using our FPWPF data context objects. So anything we change in here will be changed in the cursor, and anything we change in the cursor will be reflected in the UI. Except it's not always as simple. Let's look at Form 4. In this case, let's look at the XAML first. No, that started. We have text here. We have an expression here, which is more than we used before, because we actually now look at the Northwind table for customers, and not just a single one. So the expression we have at the bottom is this. And this doesn't really look like a FoxPro expression. And that's because of something we call WPF escape hell. So what happens? We have FoxPro, and FoxPro wants to have, and I simplify this, like something like customers.company name plus, and then in quotes, a comma. So how do we use a binding expression for that? The binding expression is handled by the WPF binding expression parser, and we put it in square brackets. That's what I told you. But I didn't tell you the full truth, just like a lot of people don't do. So this is an error, and what the binding expression parser is doing, it's meant to do, usually has indexes. So it's square bracket 0, 1, square bracket, closing square bracket for a 2-dimensional error. So it looks for a comma. And this is the first dimension, and everything at the right side of the comma is the right dimension. So we have to escape that comma. And inside the WPF binding expression parser, you do this by using the character. Now, this is the binding expression that we want the binding expression parser to see. And that's what we pass if we do it programmatically. But in order to put this into XAML, we have to go through the XAML markup extension reader. And the markup extension reader wants to have a binding expression. And as you can see, it's kind of using different characters as well that we need to escape. And for the XAML markup extension reader, we use the backspace. The backspace and then the character. Escape all the characters that are not valid for the markup extension reader, which then brings us to the XML parser, which is used to read the XAML file. And because the XML parser goes from quote to quote and then tries to interpret this as another XML entity, we also have to escape the quote. So this is how we end up with quotes, backslashes, semicolons, carets, and all of this, just to get an expression. In the code part, what we see is we actually can go through a grid and display data by having the grid in the after row code change event refresh the data context, which then updates everything in the WPF control. I also implemented the tab handling here so that we can tab from the grid back and forth. So let's look at one more thing, which is combining this with controls where you actually, when you need to bind to. Previously, we had the control available. In this sample, which looks the same but does something different, we need access to the last text box in order to bind to the on preview key down method to implement the tapping. So the way this works is we use the find name property of the control that we loaded. So we have this is the XAML turned into a WPF control. Then we invoke the find name method with the property that we, the object that we want, and then subscribe to the events. And in XAML, we just use the name property here to specify the name. So find name is the one to bind to control. So one last sample. In this case, we also add a row of buttons at the end, bind to those, and we change this from a grid to a stack panel, which has immediate impact on what it looks like, because suddenly it's not going to the end of the form, because the outermost control is now a stack panel, and the stack panel resizes everything to its smallest size, basically. If a control needs more size, it just extends, and everything is pushed down. The buttons are bound to, so you can respond to buttons. The data comes from a table, and everything updates. So it's basically just like a data entry grid, except this on the right side we have FoxPro, on the left side it's all WPF. Any questions?
Yeah, we have a few. We may not get through all of them before time. A couple go back to right at the end of the binding, that little time shift didn't work. Doug asked, can't the code check the data type of the source and do the conversion?
Yes, it can. The problem is binding is not only used for text properties, but you can also bind to other properties that are not text properties. So the binding source needs to be aware of where you're bound to. And that makes it a little more difficult because you're probably using the same data context and binding to different properties like the left property or the back color property where you have a different object. So yes, you can do it, but you need to somehow use the binding expression to indicate what type you want if you want to use it for more than text binding.
Okay. And the other one from Tom Nelf, can I use own variables like scatter memo name OData and have OData.prename as data source? Must it be public?
It has to be in scope in the form. So it's either a public variable or a private if it's a modal form, or it's a member of the form. It has to be in scope, just like a control source. Basically, you can use whatever you can use as a control source property in FoxPro, because FoxPro is using the same mechanism.
Okay. And there were a couple of questions for the end of the session, and we're there now. So
probably we cover those sessions because the session is getting over. I'll probably cover this in the after session slot.
Okay, sounds reasonable. So we'll encourage people to come over to the session room for your Q&A if they still have more questions. Okay,
exactly.
Thank you.
So once that is done, what are you doing now? So WPF is a really frustrating experience. You do a small change, like we added another control and had added a stack panel for grid control, and suddenly the UI looks different. You make a single typo in the binding expression and everything is just empty. Layout changes seem to be random. Property values, you don't know where the property value is coming from. So it's hard, but it's worth it because you really have a lot of things that you can do in WPF that you cannot do in FoxPro. And if you want to know more about this, one website is 2,000 things you should know about WPF. And it's whenever you run into something, it's probably been covered on this website. Also, Stack Overflow and Microsoft Docs have a lot of information. And once you get through all of this and get it running, then you can use a number of UI libraries, far more than we have, and make your applications really look like a modern application, not like an ancient application. So to summarize this for the session, what you learned today is, you know the difference between WPF and XAML. It's not the same. You can use WPF or you can use XAML or you can mix all of those. You know how to create and arrange controls in WPF and in XAML. You know how to handle data, handle binding. You can respond to events like click events or lost tokens events or whatever. And you know how to mix WPF controls with VFP and the problems we have to deal with, like the tab order, to make this integrated. So thank you very much thank you very much for the session. And please remember to fill out your evaluations. My team is ready to help you filling out the evaluations if you don't want to do this on your own. So thank you very much.